Hey y'all. All right, back again. Um, Today we're going over lesson 3.4, which is about different forms of linear equations. So, just a quick update. Um, Obviously, I'm not there today. I am getting better, but unfortunately, I think I'm going to be out this whole week. So, I apologize about that, but I will see y'all next week. Anyway, our essential question for today is how can we convert linear equations to slope-intercept form? So we're going to be looking at different forms of linear equations and converting them back to what we've already learned about and hopefully gotten familiar with and comfortable working with. So our learning target is being able to convert different forms of linear equations to slope-intercept form. So there's a couple steps to do this. We're going to use the first step is use the distributive property to remove any parentheses that there might be. Then we'll combine all the like terms on the same side of the equal sign. So hopefully these steps are sounding somewhat familiar. We've had to do these similar types of steps when working with other problems earlier this school year. And then number three, isolate y by balancing the equations using the properties of equality. That's basically just saying we want to get our y term onto the left side because, as we've said over and over again, all of our linear equations should start with y equals. And then our last step will just be to rewrite the equation in slope-intercept form. So we're going to talk about the different forms of linear equations that there are. So the first one, slope-intercept form, we have already been working with. That is our y equals mx plus b, and that is where m is our slope and b is the y-intercept. And again, hopefully we have gotten pretty comfortable using this format, and we're going to just take these other forms and put it back into slope-intercept form. Point slope form, we would use this format if we were given the slope of a line and maybe 1 point on that line. Excuse me. And so if we have that type of scenario, then we would use point slope form. And the format for that looks like this. Y minus y1 equals m times x minus x1. And so for that, it's m is our slope, just like in slope-intercept form. And then we have a y1 and an x1 there. And that is if we are given a point where we'll have a coordinate of an x1 and a y1 point. Okay, so that would be point slope form. And we can easily take that and convert it into slope-intercept form. And the last one's kind of a tricky one, and we're gonna dive deeper into standard form later. But just to kind of introduce it to you, the way it looks very different. It is ax plus by equals c. So I'll break this down a little bit. We would have a standard form equation like this if we had a situation where maybe we had two different rates. So instead of being given essentially one slope, if we have a scenario where maybe we're buying two different items and they cost different amounts, that would give us different rates. So maybe we're buying at a baseball game, we're buying a hot dog and a soda, and the hot dog and the soda each cost a different amount. We would plug in those different amounts or those different rates for A and B there. And then C is just going to be the total cost of the number of hot dogs and number of sodas that we buy based on their individual prices. What does that all come out to? Okay. So that's when we would use standard form. Like I said, it's a little complicated because it's very different than the other two, and but we'll go in more in depth on standard form later. We can still take it and convert it back to slope-intercept form, and I'll show you how to do that here in this lesson. Okay. The main vocab term that we want to go over today is just equivalent, and I know we've talked about this before, but equivalent just means equations that represent the same thing, or in this case, the same line, because we're talking about linear equations. all of these can be graphed as a line on a coordinate plane. And that's helpful when we're talking about converting from different formats. Really, we want to make sure that if I convert from point slope form or standard form into slope intercept form, I want to make sure that the conversion is still giving me something that is equivalent to the original equation. I don't want to be changing the value of the equation because that would change our line. All right, so let's go through an example here. So we want to convert the following from standard form to slope-intercept form. So we're given this problem right here, negative 5x plus 2y equals negative 20. So this is written in standard form, which again is ax plus by equals c. So in this case, we have negative 5 is a, 2 is b, and negative 20 is c. So if I want to convert this, really what I want to make sure that I do is ultimately I want to end up with y equals, right? Because that's what slope-intercept form is all about. So if I want to get to y equals, then I need to start isolating that y on that side. So to do that, the first step is I need to get rid of the negative 5x. So I'm going to rewrite the whole equation over here so I can work with it. Equals negative 20. All right, so I'm going to move this negative 5x over to the right side by doing the opposite and adding it on both sides. So that will cancel that one out, and I'm left with just a positive 2y equals 5x minus 20. And the last step here, I want to get y by itself, so I need to divide by 2 to get rid of that coefficient of 2. And I have to divide the other side of the equation by 2 as well. Now I'm dividing the entire other side. So the 5x and the minus 20 are both getting divided by 2. So that will cancel out the 2's over there, and I'm left with y equals 5 divided by 2. We'll just leave that as 5 over 2 times x, minus negative 20 divided by 2. That gives us 10, so minus 10. And that is our equation converted into slope-intercept form. So these two things are equal to each other. All right. And our last example here is to convert this equation, which is in point slope form. We want to convert that to slope-intercept form. So again, this one is telling us point slope form is when we have y minus y1 is equal to m times x minus x1. All right, so this is telling us our slope is negative 3, and then we have a point, sorry, that's our slope, and then we have a point that involves the number 4 and negative 2, and negative 2 is our x1, so negative 2 is our x value, and 4 is our y value. However, we want to pay close attention to the original formatting of the point slope form. It says y minus y1, but the equation says y plus 4. So what that means is that that 4 is actually a negative. In order to turn that from a y minus y1 into a y plus 4, it must be subtracting negative 4. So that turns into negative 4 there. And then x minus x1, that means that our 2 is actually going to have to be positive because it is still subtracting. And so it's not subtracting a negative 2, it is just subtracting 2. So this is the actual coordinate point that this equation is telling us. And again, the slope is negative 3. But we don't actually need to know all that right now. It is helpful to know what the slope is, but the coordinate point, we don't absolutely need to know that. I just wanted to point out that we could take that out of this equation right now. What we really want to do is we want to start from the beginning here, take this entire equation, and we want to start converting it into slope-intercept form. So the way we have to do that is the very first thing we have to do is notice we have a parentheses here. So we have to use our distributive property to distribute out that negative 3. So y plus 4 is equal to negative 3x plus 6, because we have a negative 3 times a negative 2 there. I want to leave y on that side, so I'm going to subtract 4 from both sides, and I end up with y equals negative 3x plus 2, and that's it. Yeah, that's my answer right there. So I converted this equation right here to that equation right there, and they are equal. And that's how you convert from point-slope form to slope-intercept form, or from standard form to slope-intercept form. And there should be some worksheets for you to do some practice with this. And again, apologies for me not being there this week. I should absolutely be back next week, and I do plan on reviewing all of these things that I wasn't there to teach in person. So we'll go more in depth on all of these things when I return. All right. If you have any questions, first and foremost, check in with each other, help each other out. But you can email me, you can leave a message on Google Classroom, or just hang on to it until I get back next week. All right, take care, everybody.